Alright, welcome back guys. Today we're going to be doing lesson 8.1.5, which representation should I use? So we've talked about lots of different ways to represent data. We want to start talking about which one gives us the best type of information for what we're trying to answer. So if you guys go and read along with me, when you want to represent data visually, you have several different representations to choose from. In this chapter you have used three different representations: histogram, stem and leaf plot, and box plots. Today you will compare these representations to decide which one might be a better way to communicate information from a set of data than the other two representations would be. So core problem 61. Miss Anderson's math class took a chapter test. She wants to find a way to display the data from the class test scores so students can easily understand the data. Michaela thinks that the best representation is a stem and leaf plot because it organizes information quickly. Gabe thinks that Miss Anderson should use a histogram because it gives a picture that's easier to look at. And Jerry does not agree with either Michaela or Gabe. She thinks a box plot shows important information that the other two do not show. Letter A, discuss with your team which representations Miss Anderson should use to display the data. So you're going to go ahead and pause the video and answer which of these three representations do you agree with? Which way should Miss Anderson display her data? Go ahead and take a minute. Moving on to question B. So the following are the test scores for the class: 78, 62, 91, etc. So you guys can see that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14 sets of data. 14 students must be in this class who took this test. So you guys don't have this resource page, but it says to make a stem and leaf plot, a histogram, and a box plot for this data. Our histogram should use bin widths of 10. Okay, so this lesson's really tying everything together, making sure that you guys have a good understanding of how to create these three different visuals. So up top, you'll notice that I talked about before, I like to draw lines to show that I've my 14 sets of data so I don't forget anything. I also organize them already least to greatest. So if you guys can go ahead and take a minute, pause the video, go ahead and draw these three representations on your paper, and we're going to go ahead and try to work through these three representations. So there's not really a right or wrong place to start. I'm going to go ahead and start with my stem and leaf plot. So you guys can see it's just like a T-chart with the stem and leaf. The stem is the first digit. In this case, it's our tens place, and our leaves are what come off of the stem, which is our ones place. So again, organizing them, taking the time at the beginning to organize them least to greatest saves us a lot of time in the end. So the first number we have is 51, so our stem is 5, and now we have a 1. Our next number is 55, so we already have our stem of 5, so we need 5 here to represent 55. We have another 55, so we have to list. Then we have a 62. We have a 65, 72, 76, 78, 79, okay? Then we go down to our next stem, and now we're in our 80, so we have 82, 83, and 85. And then lastly have 91 and 93, so 91, 91, and 93. So if we count up our leaves here, really that tells us how many sets of data we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's our stem and leaf plot. Then move on to our histogram. So again, 50, so if we have our bin size, there's 50 to 60, nothing's below that. We have 1, 2, 3 pieces of data that are going to fall in our 50 to 60 range. Okay? And then we have 1, 2 pieces of information that are going to fall in the 60 to 70 range. We have 1, 2, 3, 4 in the 70 to 80 range. We have 1, 2, 3 that are in the 80 to 90 range. And we have 2 that fall in the 90 to 100 range. So again, a histogram is a type of bar graph where the bars connect. And like Ms. Lanzo showed you guys yesterday, it's a good idea to tell the frequency above the bar. So again, once we organize our data least to greatest, it really didn't take that much time to go ahead and create our stem and leaf plot for our histogram. The most recent thing we talked about was a box and whisker plot. So 5 points you guys need to do a box and whisker plot. Number one is our minimum value. So our minimum is 51. Our maximum value is 93. And those are 2 of the 5 things we need. The other things we need are all different varieties of the median. So if I want to find the median of our data here, instead of crossing them off, I'm going to just check it. So that was our first, our last, and our second, and second to last until we find our middle value. And we find that we have 2 middle values, 76 and 78. So halfway between 76 and 78 would be 77. So that is our median. Okay? So we already have 3 of our 5 points. Those 3 lines represent our vertical lines of our box and whisker plot. Okay? So the other 2 points we need are our lower and our upper quartiles, or our quartile 1 or our quartile 3. All right? So I'm going to go ahead and erase my check marks. Because all we're doing now is finding the median of our lower half. So everything to the left of the median. Okay, so that doesn't include 77, but everything to the left of 77. So starting at 51, that's my first. 76 is now my last of our lower half of our information. And then 55, 72, 55, and 65. So 62 is our quartile 1, which is just the median of our lower 50% of our data. And we're going to go and do the same thing with our upper half. 78 is our low end of the upper half, and 93 is the maximum. And then we go 79, and 91, and 82, and 85. So 83 is the median of this information. So that's our quartile 3. So those are the 5 sets of information we need to do a box and whisker plot. We go ahead and make a box of our quartile 1 to quartile 3. That's 50% of our data. We then extend our 2 horizontal lines from the quartile 3 to the max, and the quartile 1 to the minimum. Now you can visualize doing this on a number line, like we did in yesterday's lesson. Okay, and this is what your box and whisker plot would look like on the number line itself. All right, so letter A, we want to think about, we talked about, are you guys recorded? What did you guys feel like was the best way to organize this information? And letter B, we went ahead and actually organized that information. So moving on to question 62, says the principal of Miss Anderson and her class's school, Mr. Sievers, wants to get information about Miss Anderson's latest test scores that we just did in problem 61. He is interested in the class median, but he also wants to know about the percentage of students who score lower than a C+, which is less than 77 points. What is the median of the class test score, and which graph lets you see this very quickly? So we want to think about the histogram. Can we very easily find out where the median is? And the answer should be no, because we don't know exactly what the values are in these different bins. On our stem and leaf plot, we know that there's 14 sets of data here, but we would need to actually go ahead and find the median or the middle of our set of data here, just like we did to find our box and whisker plot. So the box and whisker plot, we already know the median was 77. So the quickest way to find our median without doing any additional work would be to use the box plot. Question B, what percentage of the students scored lower than a C+? And which graph tells you or lets you see this most easily? So remember, a C+ was 77 points, so anything lower than a 77. All right. So if we look at our histogram, our box and whisker plot, we can see that we have 1, 2, 3, 4, 5, 6, 7 students who scored less than 77%. If we look at our stem and leaf plot, this represents 79, 78, so this person So these ones that I'm circling now, those represent students who also have less than a 77%. And our histogram, we know that 77% is somewhere in this bin. So we know that it's at most 4, 5, 6, 7, 8, 9 students. But we can't determine exactly how many students are in this bin of 70 to 80. Some of those students may be 78, 79%. Okay? So our answers can vary for this question, but it's most likely that either the stem and leaf plot or the box plot is going to help us figure this out. So if it was 7 students out of 14, that's 50% of our students. Question 63. Mrs. Smith, another math teacher, also wants to look at Miss Anderson's test scores. She wants to see information about how many students earn more than 60 points on the test. Which representations would show her this information? Okay, so go ahead and pause the video, take a minute, see if you guys can answer questions A and B, and then we'll come back and talk about it together. So for letter A, we want to know which representation showed students earning more than 60 points on the test. So if we go back to our different representations, on a histogram, we know that, hey, this is the 60 marking, and everything above that is above 60. So we have 2 plus 4 plus 3 plus 2, 2, 6, 7, 8, 9, 10, 11 students who are above 60. All right. If we go to our stem and leaf plot, and let's use a different color here. So these are all below 50, but 62 and up would also be greater than 60. So how many here am I circling? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, also 11 students. Now, the way we have our box and whisker plot drawn up here, you guys can also determine those who are 60 or higher. But in the traditional box and whisker plot, notice that we did these least to greatest. These values wouldn't actually be here. It would just be the box itself and the 5 lines. So even though the way we've drawn it, we can say exactly, we can see that, again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 students are above 60%. If we just had the box and just had the whiskers or the 5 vertical lines and the 2 horizontal lines, we wouldn't be able to tell which students were exactly above 60%. If we draw it like this, where it's a combination of the box and whisker plot with the numbers, we can use that then to determine this information. So letter B talked about, is your answer to this problem the same or different as part A of 62? Okay, answers are probably going to be different just because the nature of it is that each graphic represents different information. Our last question for today, 64. Miss Anderson still does not know what kind of representation she should use. She knows that each representation shows different kinds of information. Using the representation that you made in problem 61, list and explain what measures of central tendency or other information will be easily read from each kind of graph below. So we want to more or less create a table so that we know when would each of these visuals be most beneficial to us. So go ahead and draw in your notes, histogram, stem and leaf plot, and the box plot. Go ahead and create a table and list the different things that we can tell from these types of information. So go ahead and pause the video, take a few minutes, and we'll come back and review before we leave for the day. Alright, so if we were in class today, we would be sharing the advantages and disadvantages that you guys came up with on your own. Here were some of the common pros and cons for each of these 3 types. You guys can add to your own list. So histogram, advantages or pros, that it's easy to see when students have similar scores to one another. Okay, and that's because we lump them into different bin sizes. It's also a good estimate of the range of data, meaning the minimums and the maximums of the value. Even though we can't determine the exact values, we know about how far apart they are. A disadvantage or a con is that it's difficult or hard to find the median as well as the quartiles because we don't know the exact numbers that are in those bins. A stem and leaf plot, pros, range is easily found because we can go ahead and subtract the largest and the smallest number. Exact data values are also there. Okay, and we can use those to find the median and the quartiles, which is a con because it's not readily given to us, but we are able to use these exact values to find the median and quartiles. Okay, it's just not as quick of a process. So the box and whisker plot, the pros would be that it's quick to find the range, the median, the minimums, the maximums, and the lower and upper quartiles, because those are your 5 vertical lines that are on your box plot. A con or disadvantage is it does not show individual scores or all the possible outliers, in this case if there's more than one, meaning something other than the minimum and the maximum value. It also does not show when many students have the same score. So each of these have their advantages and disadvantages, their pros and their cons. So you guys need to become acclimated with them and decide through practice and through usage which ones are going to give you the biggest bang for your buck for the type of question you're doing. Okay, so great job today, guys, and we'll see you tomorrow.